Dr. OJ Digitalz online tutorial class this afternoon. If you are online, can you please indicate by saying yes, by typing yes. We didn't waste our time today because we have a lot of things to discuss in complex numbers. So can you hear me and can you see the board? If you are online now, please type yes so that we start in earnest. Thank you. Type yes so that we start in earnest. Are we there? Good afternoon, students. Thank you. God bless you. Can you hear me clearly? Okay, the board is okay, Tom. Thank you very much. Oh, beautiful. Thank you very much. Thank you very much. Thank you very much. Happy Sunday to you. God bless you. I wish us more pleasant Sundays ahead. Thank you. Thank you. Good afternoon. Good afternoon. So you can hear me clearly and you can see the board. That's interesting. That's interesting. All right. Thank you very much. Thank you very much. God bless you. God bless you. Now, this afternoon, our focus shall be on complex number. Our focus shall be on complex numbers. So, but next Sunday, we are going to deal entirely on revision, general revision. We're going to revise everything we have learned so far in MTS 101 and MTS 105. So let's listen and be attentive. Now, we start with solving this problem. Let's look at an interesting question in complex number. Let's look at an interesting question in complex number. Express the following, or let's say express the solution of the following equation, of the following equations. I want to express the solution of the following equations in the form A plus BI. So the first question there is 3x minus 7 is equals to 0. That's the first equation there. The second one is x squared minus 9 is equals to 0. While the third one is 3 is equals to x squared plus 30 is equals to 0. So I will give you others as assignment. I'll give you others as assignment. Now let's move on. Now, what is a complex number? You know, a complex number is a number that has a combination of real parts and imaginary parts. So a complex number has two parts. It has what? It has a real parts and it has imaginary parts. So for every complex number, there must be real parts and imaginary parts. Most times, when a complex number is given, the real part might be 0, the imaginary part might be 0. But a complex number basically consists of what? Or generally consists of what? Real parts and imaginary parts. So let's look at this question. We are asked to express the solution of the following equation in the form A plus BI. A plus BI here is a form of complex number. A and B are real values. What in the case you combine them together, the real part of this complex number is A, while the imaginary part of the complex number is B. Okay? Now, what are we asked to do here? We are asked to solve this equation and write the value or the solution of these equations in this form A plus BI. So, let's look at how this could be done. Now, let's take the first equation. The first equation is what? 3x minus 7 is equals to 0. Now, the first thing we are going to do here is to what? To collect like terms, because 7 and 0 are the same thing. 3x is different from 7. So that implies that we take 7 to the other side. So we have what? 3x is equal to 0 plus 7. Because by the time you transfer minus 7 to the other side, you have plus 7. So which will give us what? 3x is equals to 7. Okay? 3x is equals to 7. So how do we now get the value of x here? We divide both sides by 3. So by the time you divide both sides by 3, you are going to say what now? That will be 3x all over what? 3 is equal to 7 all over what? 3. So basically, 3 here, we cancel this here. We have what? X is equals to 7 all over what? All over 3. Now, the solution to this problem is x is equals to 7 all over 3. Now, how do we now write x is equal to 700 over 3 in the form a plus b high? Because we have gotten the value of x now, but we have to write it in the form a plus b high. So you observe that the value of our x here is just a what? A rational number without I. So in that case now, and since we know that the real part, the real part of a plus bi is what? Is a. Why the what? Why the imaginary part of the question given to us, of this expression is what? Is b. So that, and since 7 over 3 does not contain what? Does not contain I. It does not contain I. It's just 7 over 3. It's just a real number, natural, a kind of a rational number without the point, the element of complex numbers there. So 7 over 3 cannot be written as what? Cannot be written as 7 over 3 plus 0. Okay? 7 over 3 plus 0 is the same thing as 7 over 3. Okay? So that means it will not be what? 7 over 3 plus. That means this particular answer, 7 over 3, does not have the what? Imaginary part. Because if it does, I will be there. But since I is not in the answer we obtain, that means we are not going to write what? 0 I. 0 I. So why did I put 0 I there? Remember, we are asked to express our answer in form of a plus bi. And since it doesn't have I, the answer we obtain does not contain I at all. So we have to give that value. That means that value is 0. That means the imaginary part is 0. So now write 0. 0 will stand as b here, and your I is an indication that 0 is the imaginary part of the what? Of the problem. Okay? So that is that about that. Let's look at another one. Okay? Now, if you don't get that one, with the explanation I'm going to give in the second one, you should be able to understand it. You should be able. Don't worry. Let's go on. We take it step by step. I will not rush you. Don't worry. Now the second question. X squared minus 9 is equals to 0. Okay? What do we do here? We take 9 to the other side. So we have what? X squared is equals to what? 0 plus 9. That is what? That is 9. Okay? Now that you have gotten x squared is equals to 9, how do you now get the value of your x here? To get the value of our x, we just find the square root of what? Find the square root of both sides so that the square on x will be removed completely. So now say what? Square root of x squared, is equal to square root of 9. But remember, the square root of 9 should be what? Plus or minus. Yes, because the square root of 9 could be what? Could be plus, could be minus. Okay? So in that case now, what is the square root of x squared? The square here, we cancel the square root out. So you have x is equal to plus or minus square root 9. Okay? And what's the answer to plus or minus square root of 9? What is the answer to plus or minus square root of 9? That's going to be what? X is equal to plus or minus 3. Okay? So x is equal to what? Plus or minus 3. That now that x is equal to plus or minus 3, and you know that the answer we obtain now, plus or minus 3, does not have a what? Does not have a component of imaginary parts of the set. So that means we can write it as this. X is equal to what? Plus or minus 3 plus 0 I. Because there is no what? There is no imaginary part of the solution to the problem. So plus or minus 3 plus 0 I. Just like we did for the first question. Let's try the third one. Why the third one is going to be different a little from the first and the second question. Let's try. Let's look at the third question, whether it is going to have a different version to the first and the second one. Okay? To the first and the second one. All right, let's go there now. Now, the third one says what? X squared plus 30 is equals to 0. Okay? X squared plus 30 is equals to what? Is equals to 0. X squared plus 30 is equals to 0. So how do we get x here now? So that implies what? X squared is equals to what? 0 minus 30. Okay? Because by the time plus 30 goes to the other side, it becomes minus 30. So that gives us what? That gives us x squared is equals to what? Minus 30. Okay? That means x squared is equals to minus 30. Now, how do we get the value of x here? Find the square root of what? Both sides, like we did in the second case. That's square root of x squared is equal to what? Square root of minus 30. Okay? Now, what is the square root of x squared? That will give us what? X equal to what? Square root of minus 30. Now, this is an interesting part of complex number. You know, in real numbers, there's something like minus square root. In real numbers, you can never have a square root that has a negative sign. But in complex numbers, square roots can have negative sign. How do we now write this in form of complex numbers? Now we can write this as the square root of minus 1 times 30. Okay? We can write the square root of minus 30 as the square root of what? Minus 1 times 30. Why did I introduce minus 1? Fine. Because there is going to be a particular element that will stand as the square root of minus 1 in the course of solving this problem. How? Fine. So we can now rewrite this again as the square root of minus 1 times the square root of 30. If we split this, you can get it like that. If we split it, we have the square root of minus 1 times the square root of 30. And recall, in complex number, recall, you know, the square root of minus 1 is equal to high. Yes. In complex number, the square root of minus 1 is equal to high. Anytime you see square root of minus 1, it is going to be high. You replace it by what? By high. So that implies that, therefore, what we have here is now what? Our x now, you know, from here, our x, which is equal to what? Square root of minus 1 times the square root of 30, will now be equal to what? What? I, because minus 1, the square root of minus 1 is what? Is I. So I times the square root of 30. I times the square root of 30. Okay? So that means you can have what? I root 30. Okay? You have I root 30. So now, how do we now express it in form of x is equals to a plus bi? Fine. Let me clean this. Let us clean this and write it here. Let us clean this and write it here. How do we write it? Okay. Now, we have x now is equal to, remember we get what? I root 30. Fine. So, luckily enough for us here, we got an answer that has imaginary parts because it contains I something. So that means that this particular value does not have a real part. Does not. It doesn't have a real part because the high is being multiplied by root 30. So there's no real part there. It only has what? A complex part, an imaginary part. So which means this will not be what? 0 plus I root 30. But since the question says it should be in form of a plus bi, although this could have been, we could have left our answer like this, but because we want to write it in this form, we want to arrange it like this. Okay, now we can now say it's 0 plus root 30 I. But mind you, the I must not be inside the root 30. So this is the final answer. This is the final answer. I hope you understood this. I hope you understood this. I hope you understood this. Yes, just look at it the way I've solved the problem there. Look at it. Holistically, this one is quite different from the first and the second problems that we solved. This one is different from the first and the second problem that we solved. Okay? Are we together? All right. Beautiful. Now let's look at another question. Another interesting question. Now this is the second question now for today. We have to show that two things there. I raised to the power 7 is equals to minus I 2. 1 plus I minus 3I squared, plus I raised to the power 7 is equal to 4. Well, let's look at this. Let's look at this very interesting and relevant questions. Let's look at this. Please, are we communicating? Are we following? If you are following, please type yes. Let me see yes, sir. Yes, sir, please. I hope you have not lost we have not lost the network. I hope everything is going well. Beautiful. God is going to take perfect control today. There won't be network disruption by God's grace. All right, beautiful. So now let's solve the first one. We are asked to show that I raised power 7 is equals to minus I. How? Why? Let's see that now. What is I raised power 7? I raised power 7 is a complex value with an exponential that is odd. 7 is an odd number. 7 cannot be divided by 2. So I raised power 7 can be written as what? I times I times I times I times I in 7 places. 1, 2, 3, 4, 5 times I 6 times I 7. Okay? Now, and you see, there's something in complex number that says that I squared is equals to minus 1. I will show you. Now, let's pair it up in form of that. But let me first of all show you how I square is equals to minus 1. Note, note that, you know what? I is equals to the square root of minus 1. Beautiful, of course, yes. Now, I square will be what? Square root of minus 1 times square root of minus 1. Yes, if I is the square root of minus 1, the square of it means you multiply it twice. And so that will be what? That will be minus 1. Don't make mistake by saying that it's plus 1. No. Even in normal solved, if you say root 3 times root 3 in solved, the result is 3. Okay? Because root 3 times root 3 is root 9. And square root of 9 is 3. In complex numbers, the square root of minus 1 times the square root of minus 1 is minus 1. Don't say it's plus 1. That will be wrong. Okay? So with that now, therefore, you can go back to our I raised to power 7. Let's clear it up. Therefore, I raised to power 7 would be what? Let's take it 2. All right? This 2, this 2, and this 2. So you can have what? I raised to power what? 2 in 3 places times I raised to power 2 times I raised to power 2. Okay? Then it remains the last one, I. Okay? Now, and what is I raised to power 2? What is I raised to power 2? We said it's minus 1 times another I raised to power 2 minus 1 another I raised to power 2 minus 1 times the last one, I. The last one is I. Now, minus times minus is plus, plus times minus is minus. 1 times 1 is 1, 1 times 1 is 1. So everything here, all the signs here will be minus 1. So we have minus 1 times I. And so when you multiply minus 1 times I by I, you have what? Minus I. So I raised to power 7 is equal to minus I. I raised to power 7 is equal to minus I. Let's look at the second question in that section. Second question here. Let's look at that. Fine. We are asked to evaluate 1 plus I minus 3I squared plus I raised to power 7 is equal to 4. We are asked to show that the result of this is equal to 4. Very simple. Very, very simple. Luckily enough, we have gotten I raised to power 7 from this first example. Now we can easily plug in the value of I raised to power 7 there. Okay. Now 1 plus I minus 3I squared plus I raised to power 7. Let's check. What is it going to be? Now we have 1 plus I, beautiful, minus 3 times I squared, because that's the meaning of that. Then plus I raised to power 7, we obtain this as what? Minus I. Don't forget, that was what we got in the first problem. So by the time we expand this now, we have what? 1 plus I, then minus 3. And what is I squared? Our I squared is what is gotten to what? Minus 1. So minus 1, you plug in there. Substitution. Then plus times minus I. Beautiful. That's beautiful. Now, let's collect like terms now. Okay. We have 1 plus I minus I minus 3 times minus 1. That is plus 3. Okay. Minus 3 times minus 1 is what? Plus 3. Beautiful. Now, how do we now show this? Okay. We have minus plus I minus I. We cancel out. So we are left with what? 1 plus 3. And 1 plus 3. That is 4. Beautiful. So we have been able to show that that expression is actually correct. That expression is actually correct. So are we following, please? If you are following, please kindly type yes, say yes, say yes, say yes, say yes. Let me see yes in the comment section if you are following. Let me see yes in the comment section. Let me see yes in the comment section. Are you following? Can you hear me clearly? Is everything all right there? Beautiful, 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 beautiful. So now let's go further. Let's moving on now. Now let's move on. Let's move on. This is another question. This is another beautiful question in complex numbers. Beautiful question in complex numbers. Now suppose that Z1 is equals to 1 minus 2i and Z2 is equals to 3 minus 4i. Evaluate 1. The first question, Z1 over Z2. Beautiful. 2. The real parts of Z1 over Z2. 3. The imaginary part, Im over Z1 over Z2. Okay? I hope you understand, you already understand the shortened form of real. Real means the real part of a complex number, while Im means the imaginary part of the complex number. Now, let's solve this. Let's solve this. Good. Now, we are asked to evaluate Z1 over, note, Z1 is a complex number. Z2 is a complex number as well. Z1, the real part of complex number Z1 is 1, while the imaginary part is -2. For Z2, the real part is 3, while the imaginary part is -4. Now we have to find Z1 over Z2. So Z1 over Z2 will be what? What is Z1? 1 minus 2i all over. What's our Z2? 3 minus 4i. We can't leave it like this. That will be wrong. It's not as simple as that. Okay? We have to rationalize. When you have complex number, rational complex numbers like this that has, a complex value in the denominator, you have to rationalize it by its conjugate. Okay? By its conjugate. So what is the conjugate of the denominator? The conjugate of the denominator here is by changing, you obtain the conjugate by changing the values of the sign in the denominator. What do I mean by the value of the sign? You change the sign of the real part and the imaginary part. Just change the sign in between the two of them. The sign between the two of them. So if you look at the denominator here, we have 3 and -4i. So the sign between the real part and the imaginary part is -1. So it's minus. So you know what? You now change it to plus. Okay. So now say rationalize by the conjugate. Rationalize by the conjugate 3 plus 4i. Okay? Rationalize by the conjugate 3 plus 4i. That implies 1 minus 2i all over 3 minus 4i multiplied by 3 plus 4i all over 3 plus 4i. That is the meaning of that statement. That's the meaning of that statement. So which implies what? To make it easy, you can put them together. 1 minus 2i, yes. 3 plus 4i, beautiful. All over. Now, let me quickly tell you one secret so that I don't waste your time at all. Because you may not have enough time in your examination, since it's a computer-based test, you don't have no time to waste. Now, instead of trying to expand these two, because you are actually going to expand the numerator and denominator, look at something about these denominators. This one is negative, this one is positive. They can cancel out. Yes. And since they have the same values, don't waste your time. Multiply 3 by 3. That is what? That's the same 9. Good. Now, minus 4i multiplied by plus 4i. Minus times plus is minus. Good. 4 times 4 is 16. Good. I times I is I squared. Beautiful. Don't expand further. Yes. Don't expand further. That's just it. Okay. Now we are going to have what? You can split this as 1 into, you pick this one, you multiply by this. 3 plus 4i, good. Then you have minus 2i left. Minus 2i into 3 plus 4i. Can you see that? 2i into 3 plus 4i. There's 3 here. 2i into what? 3 plus 4i. 3 plus 4i. I hope you can see that clearly. Can you see that clearly? Okay. Then everything all over 9 minus 16 into, I square is minus 1. So you put it there. Minus 1. Okay. Now what next? We just expand the numerator. We expand the numerator and deal with the denominator. Now let's expand. 1 times 3 is what? 3 plus 1 times plus 4i plus 4i, good. Minus 2i times 3 minus 6i, beautiful. Minus 2i times plus 4i minus 8i squared, good. Everything all over what? 9 minus 16 minus 1. When we are multiplying, minus 16 times minus 1. Rather, you are not directly subtracting. Don't make mistake there. Minus 16 times minus 1. That is what? plus 16. Good. So that gives you what? Let's collect like terms here. Anything to, yes, you can have 3 plus 4i minus 6i, then minus 8 into, our high square is what? Minus 1. That's a constant all over 9 plus 16. That is what? 25. 9 plus 16 is what? Is 25. Okay? Now, so in that case, we have what? We have 3 plus 4i minus 6i. It's like you are and you are owing somebody 6 naira. So if you pay 4 naira out of the money you are owing, you are still getting what? A loan of a debt of 2 naira. So this is what? 3 minus 2i, good. 3 minus 2i, then minus 8 times minus 1. That's what? Plus 8, good, all over 25. Okay? Yeah. So what is now the final answer there? What's now the final answer there? So the answer will now be equal to what? To collect like terms, 3 plus 8 plus, minus 2i all over 25. Yes. 3 plus 8 minus 2i all over 25. So, and that will be equal to what? 3 plus 8. That's what? That would be what? 11 minus 2i all over 25. That is 11 minus 2i all over 25. So the answer to this one is 11 minus 2i all over 25. It's as simple as that. It's as simple as that. Okay? Now let's look at the next question there. The next question there. The next question there. Let's look at the next question there. Okay. The next question says we should find what? The real parts. Question number 2. The real part of Z1 over Z2. The real parts. The real parts. Now, you know, what the question is asking us directly is to find the what? The real part of what we have just obtained as our answer. 11 minus 2i all over 25. Because 11 minus 2i all over 25 is the value of Z1 over Z2. So how do we now express that in order to know the real part? Fine. You can just say that, 11 minus 2i over 25, it simply means you divide both sides, divide all the values in the numerator by 25. So that will give us 11 over 25, then minus 2i all over 25. Now, which of these values is the real part now? Therefore, the real part of Z1 all over Z2 will now become what? 11 over 25. So the real part is 11 over what? Over 25. The real part is 11 over 25. Good. In fact, some of my students have even gotten the answer. They have even gotten. God bless you. They are actually following me. I have brilliant students. My students are brilliant. I'm proud of you, students. God bless you. Now the third question. The third question, without wasting much of our time, we have to find what? The imaginary part of Z1 over Z2. So now going back to here, the imaginary part is what? The one that has I, that the one with I. That's what? Minus 2 all over 25. So the imaginary part of a particular problem is minus 2 all over 25. Please, are we following? Are we following? Are we following? Oh, God bless you. God bless you. God bless you. God bless you. Opayemi Graphics. God bless you. God bless you. Taufik Said. Atiku Olamilekan. God bless you all. Aziz Yusuf. Wow. Wow. My students are responding very well. They are responding very well. My students are responding very, very well. That shows that they are enjoying the class. That shows that they are actually enjoying this class. Good. 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 Now, if you miss this class today, oh wow, you miss forever. You miss this particular aspect forever, honestly. Now, number 4. Number 4, we want to evaluate the real parts of 1 minus I squared all over 4 plus 2i. What an interesting question. Don't be scared, it's very simple. What did I say? I trust my students, they will not be scared. I trust them. I trust them. Okay, now, how do we evaluate this? First of all, let's deal with what we have in the brackets as numerator. 1 minus I all squared. Let's attempt that. Okay, That'll be what? 1 minus I multiplied by 1 minus I. Okay? So how do we go about that? Say pick 1 multiplied by the whole of the expression here, 1 minus I. Then you have minus I left. Minus I, again multiplied by 1 minus I. So by the time you open up this, you're going to have what? You're going to have, okay, let me write it here. 1 times 1 is 1. 1 times minus I is minus I. Minus I times 1 is minus I. Minus I times minus I, that's plus I squared. Okay, so that will give us what? That will give us 1 minus I minus 2I plus, and what is I squared so far? Minus 1. I hope you can still remember that. Beautiful. Beautiful. So that will make correct letters now 1 minus 1 minus 2I. Yes, because plus times minus is minus. So 1 minus 1 plus times minus is minus. That is plus minus I is minus I. So when you bring it, you have that. So which what? This will cancel out this. You have minus 2I. So the value of 1 minus I all squared is minus 2I. Fine. We have gotten that. Good. Now, that means our expression is now what? Is now 1. So that means the whole of, we are now looking for real part of minus 2I all over 4 plus 2I. That is what we are now looking for. So this has changed to this now. Now, like I said in the last question I solved, like I said, that is there any problem here? No, there's no problem there. There's no problem there. Okay, now we now rationalize by the conjugates. Now rationalize by the conjugate of this denominator is 4 minus 2I. 4 minus 2I. So how? Let's look at that. Are we together? Beautiful. Are we together? Are you sure? Are you following, please? Are you following? Let me hear from you. Let me hear from you. Are you following? Good. Are you following? Oh, beautiful. Now, we want to rationalize by 4 minus 2. That means we are going to have what? Minus 2I all over. Let's deal with what is in bracket. 4 plus 2I times 4 minus 2I all over 4 minus 2I. Okay? Now, I want to rationalize by that. So let's go up. Let's continue it up. Let's write it up here. Good. So that means we're going to do what? We're going to have minus 2I multiplying 4 minus 2I. Yes, that is multiplying. Just open the bracket, open like this, remove the multiplication sign and put the next one in the bracket. Now, like I taught you earlier, don't say you want to expand by multiplying 4 by through everything here plus 2I. No, it will waste your time. 4 times 4 is 16. Because since they have the same value, except that the signs differ, so you can do it like that. But if both of them have the same sign, you can't do it like that. If it is 4 plus 2I, no, you cannot use that method. But since 4 here, 2I, 2 here, the only difference is just plus and minus, so you can use that method. This method, you can use it because they have negative signs. Okay? So 4 times 4 is 16 plus 2I times minus 2I. That is minus 4. Okay? So let's expand. Minus 2I times 4 minus 8I. Good. Minus 2I times minus 2I plus 4I squared. Good. All over 16 minus 4. Then what is I squared? Minus 1. So this one gives us what? Minus 8I plus 4 is what? Is minus 1 all over 16 minus 4 times minus 1 plus 4. Good. So what do we have here now? Minus 8I, then plus 4 times minus 1 minus 4 all over 20. Okay? Minus 8I minus 4 all over what? All over 20. So what next? Don't forget, the question says you should find what? The real part. Therefore, now we can split this as now what? Minus 8I all over 20, yes. Minus 4 all over 20, yes. So if you want, you can see that we have the imaginary parts coming front, and so you can rewrite it as what? Minus 4 over that is, this is the real part. Then, well, anyway, without wasting our time, don't let us waste our time. since we already know what we are asked to find. So therefore, and what is 4 over 20? That is good. The real part now will be what? Minus 4 all over 20, which is the same thing as what? The real part is minus 1 over 5. You are wondering how? Doctor, how did you get this? Don't worry. This is the real part. The real part is the one that does not contain I. Okay, and the real part in this expression is minus 4 over 20. And 4 can divide both numerator and denominator. For 4 here 1, 4 here 5. So the real part is, this is the way we are going to write it now. Now say the real part of the question. The real part. Don't let us write it this way. It will not be proper. So the real part of the question, therefore the real of, what is the question? The real part of the question. Let me write the question entirely so that it will be properly written. The real part of 1 minus I raised to power 2 all over 4 plus 2I is equal to minus 1 over 20. Yes. No, minus 1 over 5. Because 4 goes minus 1 over 5. So that is the real part. That's how to write. This is the proper way of writing that, of reporting that problem. Any question on that? Are we following, please? Are we following, please? Are we following? Okay. Okay. Yes, even some have already solved the imaginary part. I love my students. My students are what? Extraordinarily brilliant. They are brilliant. They are brilliant. Now, let's look at another question here. Yes, I think this is number 5 question or 6. I don't know. We can solve as many questions as possible if time permits. So evaluate, limits. Sorry, not limit. Imaginary, don't mind me. The imaginary version of 1 plus 3I all over 5 minus 7I. It looks like limit, but not limit. It's imaginary part. Okay. Now, you can see that this question looks exactly similar to the previous, except for the fact that it doesn't have square, but it is still a rational complex number. So, rationalized by the conjugate of the denominator. So we have what? Take the one inside the bracket. 1 plus 3I all over 5 minus 7I. Good. Good. Multiply 5 plus 7I all over 5 plus 7I. That is the way to do it. That's the way to do it. Oh, you didn't see. Let me rewrite this somewhere here. Let me write the solution somewhere here. That is 1 plus 3I all over 5 minus 7I multiplied by 5 plus 7I over 5 plus 7I. Because 5 plus 7I is the complex conjugate of 5 minus 7I. So let's solve this. Let's solve this. So we're going to have what? We're going to have, this one will be 1 plus 3I in brackets 5 plus 7I. Good. Then everything multiplied by 5 minus 7I, yes, into 5 plus 7I. But let us learn how to be fast and smart. So yeah, by now we must have known how to multiply, how to expand out. 1 times 5 is 5, good. 1 times plus 7y is plus 7y, good. Plus 3I times 5, that is plus 15I, good. Now plus 3I times plus 7I, that's plus 21I squared. Plus 21I squared. I hope you understand, because 3 times 7 is 21. I times I is I squared. Everything all over. I have told you, because they are conjugates, they are complex conjugates. So 5 times 5, just 25, good. Minus 7I multiplied by plus 7I. That is minus 49I squared. Okay, so that gives us, collect like terms now, fine. 5 plus 7I plus 15I, that's 22I, good. Plus 21 into minus 1, because I squared is minus 1. So that would all over 25 minus 49 multiplied by minus 1, because I squared is minus 1. So that gives us what? 5 plus 22I, then plus 21 times minus 1, that's minus 21, Abi. 21 times minus 1, that's minus 21. All over 25, then minus 49 times minus 1, plus 49. Plus 49. Okay? I hope that is correct. I hope that is correct. Good. So let's collect like terms. We have 5 minus 21 plus 22i all over 25 25 plus 49. I think that is what? 74. That is 74. Good. So that gives us what? 5 minus 21, that's minus 16 plus 22i all over 74. Minus 16 plus 22i all over 74. Remember, we have to find the imaginary part. So let's split. So this was what? Minus 16 over 74 plus 22i over 74. So something even goes, you can divide through, but without wasting our time, imaginary part of the question. What's the question? The question is the imaginary part of 1 plus 3i all over 5 minus 7i will be, you don't have time to waste, so it's an examination or test, 20 over 7. That's the imaginary part. But something can go there. You have 11, 2 in 22, that's 11. 2 in 74, that is 37. So the imaginary part of this problem is 11 all over 37. Wow, wow. My students are hot. My students are hot. Before I even solve the problem, they have solved it. Wow, my students are hot. I'm glad. That means you have understood what I've been doing. So let's go to the last question. The next question. It could be the last, it could not. It may not, depending on the time. Depending on the time. So let's look at the next question. Now this one says, given this, I think that this is number 6 question. Given that Z1 is equal to 4 plus 5i, that is Z2, that is another complex number, is equals to 9 minus 5i, Z3 is equal to 12 plus 5, 15i, this 15. Okay. Now evaluate. Let's write all the questions. So later we just start picking them one by one. 1. Z2, Z1 all over Z3. 2. Z1 plus Z3 all over Z2. The last one, 3. Z2 minus Z3 multiplied by Z1 all over. Okay, now let's solve this. Let's solve this. Now, the first one is Z2, Z1 over Z3. So what is Z2? 9 minus 5i multiplied by Z1. 4 plus 5i all over Z3. 12 plus 15i. Okay, so let's multiply out. We expand. 9 times 4 is 36. 9 times plus 5i, that's plus 45i. Good. Then minus 5i times 4, that is minus 20i. Good. Then minus 5i times plus minus 25i squared. Good. All over 12 plus 15i. Okay, so we can rewrite that as, let's write it on the board, on the top. You can write that as, so we have, that will now be what? 36 plus 45i minus 20i. That is plus 25i. I hope you get that. Fine. Then minus 25 times, and our high square minus 1 all over 12 plus 15i, which is what? 36 plus 25i Then minus times minus is plus. 25 times 1, that's plus 25 all over 12 plus 15i. So when you write times, you have what? 36 plus 25, good. That is 25 with this. Then plus 25i all over 12 plus 15i. I hope we are following. Are we following, please? Let me hear. Let me see you write yes. Are we following? Please type yes if we are following. Oh, beautiful. Thank you. God bless you. Thank you. Thank you. Thank you. Now, so that means that we have, when you add 36 and 25, you have what? 61 plus 25i all over 12 plus 15i. Now, you can't leave it like this. Never. You have to what? You have to rationalize. You can't leave it like this. You have to rationalize. You have to rationalize. As usual, rationalize by what? This implies 61 plus 25i all over 12 plus 15i times 12 minus 15i all over 12 minus 15i. That's rationalization by its conjugate, by the conjugate of the denominator. So we have what? 61 plus 25i into bracket 12 minus 15i, good. Okay, all over, without wasting our time, 12 times 12 is 144, good. Then plus 15 times minus 15, that's minus 225 I squared. I hope that is correct. I hope that is correct. Yes, 225 I squared. So now what next? You have to simplify. That numerator must be simplified. So let me clean this. Let me clean this so that you see clearly. So now we don't have to what? We have to multiply. We have to expand the numerator. Now 61 times 12. Okay, 61 times 12. That's 732. That's 732. You can try it yourself. 61 times 12 should be that. All right, that's 732. 61 times 12, 732. Now 61 times 15. What do you have there? 61 times 15, that is 915. Okay? So we have 61 times 12 is 732. 61 times minus 15, that is minus 915i. You can check it, but that is the answer there. That's the answer. Okay? Good. Then plus 25 times 12. 25 times what? Times 12. What is that? What is that? That's what? 300. That's 300. 25 times 12 should be 300. Okay? Yes. So that means we multiply this by this, we have plus 300i, then plus 25 times minus 15. Plus 25 times minus 15. What do we have there? You have what? 375. 375. 375. So we have what? Minus 375 I squared. This one appears big. This value looks big, you know. But if you follow strictly, you will get it. It's very simple. Okay, all over 144 minus 225. Then I squared is minus 1. Okay. So let's write it down. Let's simplify here. 732. Any other factors of 72? No. Okay, let's write it out. 732 minus 915i, then plus 300i, then minus 375 times minus 1, because our high squared is minus 1. Okay, so all over 144, then minus 225 times minus 1 plus 225. Okay, yes. How we are following? Any confusion? Okay. Now let's collect like terms. 7, this will be what? 732. This one minus 375 minus 1. That is plus 375. Yes. Okay. Then we have what? Minus 915i plus 300i all over 144 plus 225. That is what? 369. 369. I hope that is correct. 963. Beautiful. So that will be what now? Let's subtract. Okay, we had it here. This is 7. Okay, 10, 11. Now just 10, 0, and 11. Then minus 915 plus 300. That's what? That's minus 615. Minus 615 I all over 369. Oh, this value looks this value looks very big, very big. You know, very big. But that notwithstanding, what is important is for you to get the answer correctly. So if you want to write, you can leave it like this, but it's not really proper. Let's write it in a proper complex way. So we have this one, but 1107 all over 369, then minus 615I all over 369. I guess 3 goes. Can 3 go here? 3 in 11, that's 3. Here's, no, 3 in 11, that's 3. Remaining what? Remaining 2. 3 times 3 is 9. 3 in 20, that's 6. Good. That's 18. It remains 2 again. In 27, 9. Oh, beautiful. 3 can go. 3 can also go. Wow. So that means the whole of this, if you multiply this one, 369 in this can be 3. So if you divide the 1107 by 3, so the whole of this is now what? 3, correct? 3, minus, can 3 goes here too? Let's check. 3 in 6, that's 2. In 1, 0. In 15, 5. Good. All over 3 in 369. 1, 2, and 3. I. Yes. I. 1, 2, and 3. 1, 2, 3. So the answer is 3 minus 2 all over 5. 3 minus 2 over 5. Oh, you can't see. Wow, let me write it here. Sorry. So the answer will be what? 3 minus 2 over 5 all over 123I. So that's the answer. 3 minus 2 over 5 all over 123I. The answer is that. The thing still appears not clear. Oh, you can't see the board. Wow. Okay, we'll see it now. Let me write it here then. That what? 3 minus, what did I do here now? 205, all over 123I. I hope you can see it now. 3 minus 205I all over 3 minus 2 over 205, 205I over 123. So this 3 is like 3 over 1. Hope that is clear. Please, are we following? Do you understand? Are we following, please? Are we together? Oh, beautiful. My children, my students are following perfectly. They are following. I'm proud to have you as my students. God bless you all. Now, let's look at the next one here. The next one says that Z1 plus Z3 all over Z2. Okay. And what is our Z1? We have 4 plus 5I plus, what is our Z3? 12 plus 15I all over, what's our Z2? 9 minus 5I. Okay. So now let's collect like terms. 4 plus 12, 16. We are adding. Okay. I hope you understand. 4 plus 12, because they are real numbers. They are real parts. They don't have I. Then plus 5I plus 15I. That is plus 20I. Plus 20I all over 9 minus 5I. So we still have what? We still have to rationalize. So now rationalize. That is 16 plus 20I all over 9 minus 5I times 9 plus 5I all over 9 plus 5I. Which is what? 16 plus 20I. Put it in bracket like this. 9 plus 5I. Yes. All over. Don't waste your time. 9 times 9 is 81. Minus 5 times plus 5. That's minus 25I squared. Please, are we together? Are we together? I want to hear from you. Are we together? Are we following? I hope the network is still stable. Hello, students. Oh, thank you. Thank you. Thank you. So by the time we expand this, let me expand it. Let me write it on top. Let me write on top. So let me write on top. Now, by the time we expand this, okay, we have 16 times 9. You know, this is 154, 144. Okay, so we have 16 times 9 is 144 because 6 times 9 is 54. Yes, I hope you understand that. And the remainder have 5. Okay, now then 16 times 5i. You know, I've multiplied 16 by 9. I'll now multiply 5i by 16. That's plus 80i. Are we following? Okay. Then plus 20i times 9 plus 180i. Then plus 20i times plus 5i plus 100i squared. Good. All over 81 minus 25. I squared is minus 1. So that gives us 144 plus 80i plus 180i. Let's add them together. We are adding them together. That's 260. Am I right? 260i. Am I right? Yes. That's 26. Okay. Then plus 100 into minus 1 because I squared is minus 1. So everything all over 81. The minus 25 times minus 1 plus 25. Okay. Now, so what follows? Just substitute. Simplify and get your answer. So that will give us what now? 144 plus 260i minus 100 because 100 times minus 1 is minus 100 all over 96. Sorry, that can't be 96. That's an apology. That's 106. Okay, so this will be what? 144 minus 100. That's 44 plus 260i all over 106. 106. So let's write it properly. So we have 44 all over 106 plus 260i all over 106. Can something go in them? Yes. I think 4. Can 4 go here at all? No, 4 cannot go here. 22, 2 here, 53. Beautiful. 2 again. It's only 2. It's only 2. 2 here, 130. 2 here, 53. So we now have what? We now have 22 all over 53 plus 130 over 53i. 22 over 53 plus 130 over 53i. Okay? Yes. My children are hot. Oh, very hot. Now the last question there. Now we want to evaluate Z2 minus Z3 all over Z2 multiplied by Z1. And so we have Z2 was given to be 9 minus 5i, then minus, let's open up the bracket there. Z3 is given to be 12 plus 15i, then everything all over 4 plus 5i. No, Z2 again, that's 9 minus 5i. Sorry. So opening up, we have 9 minus 5i minus 12 minus 15i. We are expanding with minus sign all over 9 5i. Please, are we following? Good. So we collect like time. 9 minus 12 minus 5i minus 15i all over 9 minus 5i. Don't forget, we are still multiplying by this zi. Okay, but let us solve this one first. Let's solve this one, the one in bracket, the later, or better still, let's put our Z1 there so that we will not forget. Z1 is what? 4 plus 5i, so that we will not forget. Okay, now we now have 9 minus 12 is what? Minus 3. Yes. Minus 5i minus 15i minus 20i all over 9 minus 5i. Okay, then let's expand the one up there, 4 plus 5i. Okay, so now by normal expansion, minus 3 times 4 minus 12 minus 3 times plus 5i minus 15i minus 20i times 4 minus 80i minus 20i times plus 5i minus 100i squared. Can you see that at all? Will you be able to see that? Oh no, you can't see. Let me write this one up. Let me write it up. Let me write it up, please. Let me write it up. What I did there, if you can't see, let me write it there. So that will be what? I mean this summation, this expansion, minus 15i minus 80i minus 100i squared all over. So we cannot say that. I've written it on the top. I mean on top. So all over 9 minus 5i. Okay. So in this case, we just have to support, collect like terms and rationalize. So this one will be what? Minus 12 minus 15i minus 80i. That's minus 95i. I think that's correct. Yes. Then minus 100 times I squared is minus 1. So 9 minus 5i. So that will give us what? Minus 12 minus 95i plus 100, because 100 times minus 1. You know you are multiplying. Okay. All over 9 minus 5i. So you now have what? Minus 12 plus 100. Now minus 12 plus 100. Minus 12 plus 100. Now this you collect like terms. Then minus 95i all over 9 minus 5i. Please, are we following at all? If we are following, I want to hear from you. Let me see you type yes. If you are following, let's type yes. Let's type yes. Let's type yes. I hope we have not lost the connection. So I want to see you type yes, please. Beautiful. Oh, God bless you. God bless you. God bless you. God bless you. So that means minus 12 plus 100. You know, that's what? 88. That's 88, I think. Yes, that's 88. Minus 95i all over 9 minus 5i. So the next is now what? To rationalize. Rationalize by the conjugates of the denominator. So that means we are going to have what? 88 minus 95i all over 9 minus 5i. Then we are multiplying by what? Without wasting our time, 9 plus 5i all over plus 5i. We have done that several times today. Just multiply by its conjugate. And the conjugate of 9 minus 5i is 9 plus 5i. So now let's expand. 88 times 9. 80, this is a very big number. 72 plus 7, because 9 times 8 is 72 plus another 792. So 792, yes. Then 88 times 5. 88 times 5, that's 440. Okay, so 88 times 5i is plus 440i. You have to be careful so that you don't miss the sign. 88 times 9 is 792. 88 times plus 5i is plus 440i. Then 95 times 9, that's 45, 4, 81, 85. So that's what? 95 minus 95i plus, I mean times 9. That's minus 855i. Good. Yes. Then minus 95i times plus 5i. That's minus, you are multiplying 95 by 5. That's 25, 45, 47. That's what? Minus 475 I squared. Everything all over what? This one's, as usual, 9 times 9, 81. Minus 5i times plus 5i, minus 25i squared. Okay, so let's collect like terms. Let's write it out. 792 plus 440i minus, you can solve this one directly. 440i minus 855i. So what do we have there? 415. I think that will be 415. That's minus 415. Minus 415i minus 475 multiplied by minus 1 all over 81 minus 25 times minus 1. I hope I'm not making I'm not performing magic here, because we have carried out this operation severally today, and I don't expect us to have issues concerning all this. Okay, so we have 792 minus 415i plus 475, because minus 475 times minus 1, that's plus 75, all over 81 minus 25 times minus 1 plus 25. So that will be, collecting like term, 792 plus 475 minus 415i all over, this is what, 106. Is that right? Oh yes, I hope that is correct. Okay, so what next? We want to add now. We had as 2 plus 5, that's 7. 7 plus 9, that's 16, remaining 1. 7 plus 4, 11 plus 1, 12, minus 415i all over 106. So if you want to write it properly, now what? 1267 all over 106 minus 415i all over 106. So that is the answer for that as well. That's the answer for that as well. Please, did you understand all this? Did you understand all this? I think I want us to stop here for today, so that you'll be able to prepare ahead of tomorrow. But note, on Sunday next week is going to be final. A lot of questions will be solved that will be relevant to your test questions, even exam questions. So I will advise you to inform your friends, your colleagues that are offering the same course, whether it is MTS 101, 105 or thereabout, to make themselves available next Sunday. If you are not there on Sunday, you are not anywhere. So for now, I don't really have much questions. I want to do revision on the one I've taught you, but I want you to express these questions, express the solution, just the first example of the following equation in the form a plus bi. What are the equations? 1, x squared plus 3x plus 10 equals to 0. 2, x squared plus 49 equals to 0. So on this note, I'm going to call it a day for today's online class. I want to believe that you enjoy this particular tutorial class. We shall be talking about the modulus of complex number next week. I want us to stop here for today, so that you have enough time to prepare for tomorrow's classes. So God bless you as you watch, and you keep watching, and you keep solving mathematics. I love you all. Bye.